Okay. These directions say to solve, and then check your answers if they're extraneous. So number 1, how do I do that? Yeah, one fraction on each side means cross multiply. Okay, so one side of the equation should be
5x plus 1.
Yeah, I hear a lot of light bulbs going off. Okay, love that. Equals
3 parentheses 2x plus 9.
good. And now what?
Oh, you distribute.
You distribute. Good. And when I distribute, what do I get?
20x plus 4.
20x plus 4.
It's 6x plus 18.
Careful.
27.
27. Thanks for the correction. Okay.
Wait, oh yeah, that's my bad.
27.
Now what do I do?
I just screwed my whole answer minus.
Minus what? You could, yeah, okay. We're trying to get the variables to one side, numbers to the other, right? Okay, so if you minus the 4 over, that works. And then minus 6x over. So I end up with 14x equals 23. And last but not least, divide by 14. And can I simplify 23 over 14? No. Okay, if you gave me the decimal, that's okay. I'd honestly prefer that you leave it as a fraction. But sometimes we get ugly answers in Algebra 2, right? Okay, and that's totally okay. A lot of times we get an answer like this and we're questioning our life. Like, why is that not a whole number? Okay? Sometimes we have ugly answers. That's okay. This is correct, okay? Last thing I want to do is I want to check for extraneous. And how do I do that? We talked about it.
I know that.
We take this and we plug it back into the original denominators for x, right? And we just check to be sure that neither one of those denominators become 0. And if they don't, then we're good, right? Okay, but if they do, then this answer doesn't work, right? That's all there is to that, okay? So if I plug those in either one of those original denominators, if I plug in 23 over 14, neither one of those go to 0. So this is a good answer. I don't need to cross it off, okay? What questions do you have? Are we good with that? Okay. Next one is very similar. What do I do here? You cross multiply. You got one fraction on each side. Okay, be careful though. One of the sides of this equation has 2 binomials. Put them in parentheses, just like always. Okay, the other side's really easy. What's 5 times 10? 50. Okay, from here, now what do I need to do? Foil. Good, good, good. Okay, make sure we foil this out. What is x times x?
X squared.
X times 2?
2x.
Negative 3 times x?
Negative 3x.
And negative 3 times 2. Now what?
You add the 6?
What'd you say?
Add the 6?
I wouldn't add 6 over.
You
Got to be
combine
careful.
like terms, then you do the x method.
Combine like terms and do x method. So, yeah, you got to subtract 50 first. Okay, love it.
Oh, that's right.
So we can do these 2 steps at the same time. But 2 and negative 3x give me negative x, good. And then negative 6 minus 50. Negative 56. Are we all good with that? Okay, zero product property tells me move everything to one side to solve, okay? The difference between number 1 and number 2 on this step was on number 1, I didn't have anything higher than x to the first, right? So this was technically a middle school problem, okay? That was get x's to one side, get the numbers to the other, divide, okay? That's the difference. This is x squared. Anything higher than x to the first, that's algebra 2, right? That's factoring. That's zero product property. So move everything to one side, factor to solve. Okay, how do I factor that? Next method, good. What goes at the top?
Negative 56.
And at the bottom?
Negative 86.
And what's going to multiply and add? Multiply to negative 56, add to negative 1. What?
Negative 8 and 7.
Negative 8, positive 7? And the shortcut works, right? Because this is a 1. So I can just put my x's here. Those are my factors. And last but not least, what? Last part of ZPP tells me to set them equal to 0. Good. And what are my solutions going to be? 8 and -7. Love it. Okay. Last but not least, do both of those answers work? So if I go back to my original denominator, my first denominator is just a 5, so I can't plug anything into that. But my second denominator is x plus 2. So if I put 8 in there, or if I put -7, if I add 2 to either one of those, will it be 0? No. So these are both good answers. Know that the whole like no solution thing or a solution being extraneous is a very rare thing. That does not happen very often, okay? So if you turn in your tests and every single solving problem you put no solution for, just know that your grade's not going to be very good, okay? Because this, again, does not happen very often. I'm not telling you that it doesn't happen on the test, but I'm telling you if it does, it's not going to happen very often, okay? Are we cool with that? Okay. Any more questions on this? We feeling okay? Okay. Graphing, okay? The next thing we are graphing, these are called reciprocal functions, okay? And just like everything we graph in this class, we start off by talking about the parent function. So what the parent function is, it's the function before I've done anything to it, right? Before I've done any transformations at all. So what I want you to write in this box, whoops, y equals 1 over x. That is my parent function for a reciprocal. Okay? The other thing you might hear these called, you might hear them called hyperbolas. But I'm not going to really call them that very often. It's just a word you might need to know before you get to college algebra. Okay? How we're going to do this, okay? Just like we graph everything in this class. We start off, we go type it into Desmos, right? So that's what I want you to do right now. So get out your iPad, go type in y equals 1 over x on Desmos.com, or preferably the app if you have it downloaded. If you don't have an iPad, okay, then find someone who does, or go log into one of these computers over to the side, okay? And please type this in for me. Alrighty, I heard a lot of wowzers, okay? These don't look very pretty, do they? They don't, okay? So if we go look at Desmos, alright, so asymptotes, that's what those are called. Say that word with me, asymptotes. Say it again, asymptote. It's kind of fun to say. Okay, so how we do this, what these are, okay? They are basically in math, okay? We think of them as invisible walls, okay? They are invisible walls that my graph is going to get infinitely close to, okay? Really, really close, but it's never going to touch this wall. It's never going to cross this wall. Again, it's just going to get close to it, okay? So if you notice, as you zoom in or zoom out on Desmos here, neither one of those pieces of this graph are touching either of the axes, and that's because that's where the asymptotes are for the parent function. Okay? I do want you to draw these, but I do want you to listen here. Okay? Be careful. These are invisible walls, right? So do not draw a solid line, or I'm going to think that that is a part of your graph. I want you to draw these dashed or with a highlighter. Okay, those are your two options. So a dashed line with your pencil or with a highlighter, you can draw these in. And I do expect you to be able to draw these and identify them on the quiz, or sorry, not the quiz, but the test for this unit. So go ahead, and if you have a highlighter, use a highlighter. If you don't, just dash line with your pencil, just like this. Okay, the vertical line means the one going up or down, right? That is through 0. That's through the equation x equals 0. And the horizontal is through y equals 0. Will they always be that? No, but this is the parent function. That's why they are both 0. Okay. Now we want to draw this in. So just like anything we graph, we want some real points on this, right? So give me some points that are on this graph. Go to Desmos and click with your finger and find some points. What do we got?
Wait, what?
Give me some points.
Points?
Yeah, you could just tap it and it gives you it. Sometimes it gives you decimal points, and those are okay.
There's 2 and 1. No, there's not. 2 and 0.5.
2, 0.5.
Yeah.
Okay.
And there's 1 and 1.
1, 1 is on there. What else? Is 0.52 on there, I think. Okay, so there's one piece of this graph.
Oh crap.
Okay. Give me some more points on this thing.
You can go negative.
Let's go to the other piece, because I have the
-1,
piece in the
-1.
top. -1, -1.
Can't you just mirror all those?
You could, yeah, for the parent function. So -0.5, -2, -2, -0.5. Okay. All right, so here's what I need you to listen to, guys. Okay? These are graded for accuracy, right? Okay? They don't have to be exactly perfect, but they need to have real points, not points you made up, okay? And really the big thing that I count off on, okay, and that all teachers count off on for these, is that if your line crosses, or sorry, your graph crosses your asymptote, I have to count off for that, because that means you don't know what an asymptote is, okay? Those asymptotes are boundary lines. Think of them that way, okay? You can't cross them. You really aren't even supposed to touch them, but especially just don't make sure your graph crosses over whatever those are. Make sure it stays in the right boundaries, okay? Are we cool with that? You don't have to be a perfect artist. These don't have to look just like Desmos does, but they do need to be accurate points and a good sketch in the right place. Are we good with that? Okay. So that should be pretty easy because Desmos gives that to you. Okay. The next part I want to talk about is domain and range. Okay. Domain, let's go over here to the side real quick and just write this out so we are all clear. What is domain? What has it always been? And it always will be? X from the left to the right. And I like how Gunnar said, okay? He said it's negative infinity, positive infinity. That is typically what things have been that we've graphed so far in the past, okay? This is going to be a little different though, okay? I agree with Gunnar that this is going to the left forever, to negative infinity, don't you? If I look at this graph, we see an arrow going to the left, okay? I also agree with him that this is going to the right forever, okay? Because we also see an arrow going right forever. However, what else do we got? We got a wall, right? Okay, so that's our issue here. Is that, yes, we're going left forever, but as I move to the right, bam, I smack that wall, okay? And then I pick back up on the other side of it with my next piece, and I go to the right forever. So, how do I write that mathematically? Just like this. Yep. With a parenthesis, right? And then we're going to put a little U, a little union. And we'd have 0 to infinity. Okay, let me explain this. So, we've talked about already in here how parentheses mean does not equal, right? If it's equal to, we use a bracket. Okay, so that's why this works. Okay, what I'm saying here is that domain goes from negative infinity to 0, stops at 0, does not equal 0, okay, and then goes from 0 to infinity. Again, not ever equaling 0 because there's an asymptote. Are you with me? Okay. That was a lot. Let's take a deep breath. What questions do you have? That makes it easier to understand? Okay. What about range? What's range? Well, it's not X though. What is it? Y. And it's down to up, right? Or bottom to top. Okay, just like domain is negative positive, right? Left to right, range is negative positive, bottom to top. Okay? So, very similar thing we got going here, right? Okay? Is this going down forever? It is. So it's starting at negative infinity, but as I rise upward, bam, I smack a wall. Okay, where is it? 0, okay? And then I go from 0 to positive infinity. Okay. They're both the same because both asymptotes were 0, okay? But when I start doing transformations, when I start changing those asymptotes, that's when the numbers change. But the setup won't, right? It'll always be negative infinity to the asymptote, asymptote to infinity, okay? Kennedy thinks it's dumb. That's in the video. Everyone's going to hear you say that for years to come. It's okay. Okay. Tell everyone that Kennedy thinks it's dumb. Okay. They all know now. I think it's great. I think it's fun. Okay. Here we go. Here we go. Standard form. Okay, so here's my standard form equation. Again, this is once I put the transformations in. And guess what? This box, this transformations box. Okay, I cut part of it out. All right. So once again, we've already seen this. We've seen it a lot. Okay, so H is the. Let's play Hangman. Horizontal. Okay, there we go. And is H my good or my bad friend?
Good friend.
No. Oh my gosh, you guys forgot everything we know over Christmas break. Okay. Horizontal is my bad friend. So think of a person whose name starts with H and then just consider them your enemy for the rest of the semester. Okay? Okay. Braden doesn't start with H. So
Close enough.
okay. All right. So what I mean by that, okay, if we're speaking horizontally, in my mind, guys, listen. In my mind, I would think plus meant to go to the right, but does it? No, because it's my bad friend. It's deceiving. It means go left. Okay? Also, Gunnar doesn't start with H. You guys are silly. Okay, and then what about a minus? It means go right, because again, it's my bad friend. It's deceiving. Okay, it's the opposite of what I would think it was. Okay. K, what's K?
It's your good friend.
It is my good friend, and it's my vertical friend. Good.
40.
So, vertically speaking, if I see a plus sign, that means go up. Good. Okay, and if I see a minus sign, that means go down.
Yeah.
Okay.
Good one, Gunner.
I thought she was still talking about bus.
Guys, let's reel it in. Reel it in.
I also said down. Or up.
Again, this is recording right now, so everyone's going to hear this for years to come. I love that for you. Okay. A. Lastly, A. A is my friend that's got a lot going on, right? We all have one of those.
Why are you looking at me?
Brain paper.
Okay. If A is negative, the function is what across the what?
Across the X. Reflect across the
Reflected across the X. Good. Okay, so once again, the sign of A just tells me if it's positive, it does not reflect, right? If it's negative, it does. Now we're talking about the digit of A, okay? If that digit is bigger than 1, it's a vertical stretch. And if it's less than 1, compress or shrink. Let's put both because we need to know both. They're synonyms, we call it.
Synonyms?
Synonyms. Okay, and then the last part of this box that is new, because again, we haven't seen these before, are the asymptotes, okay? And what I need you to know, X equals H, Y equals K. Okay, so once again, those are something we need to memorize, okay? X equals H is vertical, Y equals K is horizontal, okay? A helpful hint, when I look at the standard form equation, okay, X and H are always right next to each other, right? Okay, so that could be an easy way to remember that it's x equals h, and then y equals k on the outsides, okay? Cool. What questions do you have?
Chilling.
We're chilling. Okay, we are about to dive into the graphing, but before we do, we real quick got to talk about transformations. So just like every single thing we've graphed so far, if I give you the transformations, can you put it in the standard form equation? Yes, okay? So looking at this equation, can I plug in what A, H, and K are? Just like before, okay? So we'll do the first one together. We already know it's going to be y equals. We already know that there's going to be an x on the bottom of the fraction, but we don't know a, h, or k. So let's read through this, okay? Reciprocal parent function is reflected across the x, translated 4 units right, 3 units down. Okay, let's start with A. What do we think? What? It's not B. What is A? What number is A going to be? 1, okay, because it doesn't tell me to stretch or shrink, right? So it's a 1. What else, though? What does it tell me?
I'm confused if it's negative or not.
Is it negative or not?
It's negative.
It is negative. Yeah.
How's
Okay, why is it negative? Reflected. Okay, so once again, negative is if it's reflected, okay? And then if I have a stretch or shrink, that's where I throw a number in there. But if I don't have a stretch or shrink, we automatically assume it's a 1. Okay, so this time it's a negative 1. Good. Okay, and then H, what do we think there? H is always right or left. So what do you see? 4 units right, which means negative 4. Bad friend, bad friend. Good. And then what about K?
-3.
Negative 3. Good friend. So if it says down, it means it. Okay? Now we go and write the asymptotes, because that's the last part. It asked me to identify the asymptotes. Okay? What does x equal? Actually, it's going to be positive 4, because I'm pulling it back out, remember? Okay? We've not done this before. This is new. And then y is going to be, it's always the same though, so it'd stay negative 3. Yep, it's not the deceiving one. H is the only friend you got that's bad, okay? K is your good friend. Cool.
Oh, so you flip the sign on.
You always flip it, yep. It's always the opposite of what you think. Fun. I know this is so much fun. Okay, I'm going to give you a minute. I want you to try 2 and 3. Okay, we're running out of time. On number 2, y equals, what do we think?
2. Oh, or no, is it? No.
Yep, that's right. 2 over
X
plus 1.
4. Where'd you get
Where did you get? I'm sorry, X plus 1.
x plus 1? And then,
I looked at 1. I was looking at
that's
1.
okay. And then what
Plus
else?
7.
Plus 7. Good. What would be my asymptotes? X equals and y equals. Beautiful. Okay. Number 3, it just gives me the asymptotes. Ask me to write an equation.
I think I got it.
You think you got it?
Yeah.
What do you think?
Is it 1 over x plus 2
No, it's not just 1.
plus 5?
Do we agree? I do. Okay, that's
I don't.
perfect. You don't agree? Well, then you're wrong.
I just see it.
Okay, technically on that one, it didn't tell me stretch, shrink, or reflect, so really it wouldn't matter what you put on top, but we just like to automatically assume if we don't know, we put 1, okay? Cool? Cool?
Yeah.
We good?
Yeah.
This is easy. All right, here we go. We are diving into graphing, and we're running out of time, so we got to go quickly, okay? The first thing, ladies. Let's go. Type this into Desmos, okay? You'll notice it says f of x equals, but that's the same thing as y equals. They mean the same thing, so don't let that trip you up, okay? So go type that in. Ready, set, go. It's the same, but it's lower. So what are you saying there? You have the asymptote shifted down to where? A little bit lower. -2. Okay. So we have an asymptote at -2. What about the vertical asymptote? Did it shift from the parent? No, it's still 0. Okay. So guys, look. Everybody up here. Okay. Notice how H, which is always on the bottom with the X, is there an H written right there?
No.
No, so that means H is
But
0. Yeah, X equals 0 is my vertical asymptote, okay? Same as the parent function. And then the horizontal is always K. Do you notice how K is what number? On the back?
-2.
-2. Do you notice how K is at -2 there? Okay, so you don't have to look at Desmos to find those asymptotes. You can just look at the equation, okay? That, in fact, is what you probably should do. But Desmos will show it to you as well, okay? Then I want some real points on this. What do you got for me? Give me a couple.
0.50.
0.50. Let's try to get like 2 on each piece, so...
Bingo. I don't know.
1, -1, okay? So now I'm going to sketch this. Again, I got 2 real points, so that kind of gives me an idea. Okay, give me 2 points on the other piece. -1, -3, give me one more. You're just using Desmos for this, guys. You're not just making these up.
-2. -2.5.
Okay, -2, -2.5. Beautiful. Once again, the big part here is just to stay within those asymptote lines. Don't cross them. Okay, now we start with domain, okay? Left to right, X values, okay? What do we think this starts at? Where does it always start? Go back and look at your notes. -infinity, okay? And then as I move to the right, bam, I smack a wall at what number? 0, okay? Look, left to right, bam, stop at 0, okay? So then, union, 0, positive infinity. Are we okay with that? That's domain, okay? Range is very similar, but range is the Y values, okay? Where are we starting?
Oh, definitely.
-infinity, good. And we are now going to hit a wall at -2. Okay, and then what else?
-2.
-2 positive infinity. Okay, so same setup as the parent function. Again, the asymptotes changed, so those numbers changed. Okay, how do we feel about that? It'll always be like that, so it should be good. We don't even know what a hole is, so we're not going to deal with that right now. That will come up next class. We'll talk about that. Okay? End behaviors. So just like before, okay, this is asking me, at the far left end, what is X doing? What's Y doing? Okay, we just said X is going left forever, right? So we put -infinity, okay? And if I follow this thing as X goes left forever, I look at that arrow, I see it's kind of like an up arrow, right? Okay? However, can that go up forever? It's going to hit that asymptote line, which is at what number? -2. Oh my goodness. Okay? Same thing on the other side, okay? This time as we follow it as X goes to the right forever, so to positive infinity. Okay, right now it looks like that's like a downwards arrow, okay? But can that go down forever? It sure can't, because it's going to stop where? At -2. It has to. It can't cross that line, okay? How the heck am I going to remember this? Okay, I know that's what you're thinking. You're like, this is a lot, okay? I'm stressed out. Do you notice how the horizontal asymptote is at -2? And both of these Y values stop at -2. Those three things will always be the same number, okay? Every single time. So just follow that rule there, okay? Whatever my horizontal asymptote is, that's where Y is going. That's where Y is going for both sides, okay? Questions on that? Okay. Next up, we have increasing and decreasing interval, okay? When we think of intervals, what do we think of? Roller coaster, I heard it, okay? Always. We think of a roller coaster, and we think of a roller coaster moving from the left to the right, okay? These are pretty easy. If I follow this graph from left to right, okay, let's start with the first piece on the bottom. As I move from left to right, am I increasing or am I decreasing? I'm decreasing, okay? If I go up to the top piece, I do the same thing from left to right. What am I doing? Decreasing the whole time, right? So we copy the domain on the decreasing line. It's always the domain. Always, no matter what, okay? Which means on increasing, I put NA. I don't have one. So you will copy the whole domain on one of those two lines. In this case, it was decreasing. Are we good with that? Okay? Last but not least, there's no reason why you should miss X and Y intercept because you're using Desmos. Go look at Desmos and see where do I cross X axis, where do I cross the Y axis. So X is what, Gunnar? 0.50 and the Y. Do I cross the Y axis on this one? No, because why? Because the asymptote's there. Okay, it won't always be there, so sometimes you'll have a number, but in this case, it's there. How do we feel about this?
I guess it's pretty easy.
It's really no different. I mean, it's different. It's a weird graph, but none of the concepts have changed. The only thing new is the asymptote thing. Okay? Cool? Okay, I'm going to give you about 4 minutes. I want you to try to get a head start on 5 and 6. We're running out of time because it's Wednesday. But after the 4 minutes, we're going to go over both of these and call it a day. There we go. Desmos, okay? Go type this in. Hopefully you already did, okay? First, draw the asymptotes with your highlighter, right? Or your dashed line, okay? So, let's see. Where are these asymptotes at?
One's at -3. The X is on -3. Or the
Negative
Y.
3. Okay, would that be the horizontal or the vertical? Careful. What'd you say? Vertical? Yeah, vertical. Okay. There we go. And then what about the horizontal?
That's up
0. Okay, because there's no K on this one. Do we all see that? Okay, so for the asymptotes then, Gunnar just gave it to me. He said horizontal was at 0, y equals 0. Vertical was at -3. Okay, and again, I could get that by just looking at those equations. And we don't know what holes are, so we'll put an X there. Okay, give me a couple points on this. We're going kind of quick. Just give me like 1 point on each side and I'm going to sketch it, but I would like you to have 2 points on each side.
-2, -1.
Okay, I don't think that's on there.
Never mind. Yeah. Yeah, it is.
-2, 1, you mean?
Yeah.
Okay, you said -1. You're okay. I'm just sketching here. All right, and then 1 point on the other piece, because again, we're running out of time. That shouldn't look like a 90-degree angle. It should look more curved, but
Wait, can't you do? Well, there's. Oh.
give me
We're
one.
doing the next one.
Is it like -4,
It's -4, 1.
-1, you mean?
Yeah.
Okay. Is everybody with me so far? Have I lost anyone yet? Ladies in the back, have I lost you yet? So we just found the asymptotes, and then we drew what Desmos gave us. Okay, so the asymptotes are x equals h, so if I look, -3, just like what we did on the first page, right? Because if I pull it out, it's a -3. And then k, we don't have anything, so that means it's a 0. So those are my asymptotes. Are we good with that? And I can look at Desmos when I type this in and see that that's where the walls are, right? Okay, cool. Now, we go to domain, so left to right. What do we think? Negative infinity to -3, yeah. Okay, just look at the graph. So then -3 to positive infinity, right? It's always going to follow that setup. Just the number's going to change depending on what the asymptote is. So from left to right, I smack a wall at -3. Now we talk range, bottom to top, same setup, okay? In fact, I could go ahead and just set it up like this, right? And then go plug my number in. And from the bottom to the top, what number do I stop at? What asymptote, I should say? 0. Okay, so we see that? Do we see on the range how what I wrote in red is going to be the same for literally every single graph we do, and then what I just put in the blue is the same as the asymptote? Do you see that? Okay, it's going to be that every time. Okay, the in behaviors. What do I copy for the x's?
Negative.
Yeah, left forever, right forever. And then what are the y's going to be for both left and right side? Yeah, they're stopping at that horizontal asymptote. So once again, HA and both y's are the same number. They should always be that. Okay? Now, I ride this thing like a roller coaster from left to right. Would this be going decreasing or increasing?
Well, the first, decrease.
Decreasing for both, right? Okay, so we copied the whole domain.
Will it ever be increasing?
Yeah, we're gonna see that on the next one, and we gotta hurry. Okay, give me the x and y intercepts. Fast, fast. What do we got?
Oh, 0 and 0.33333333333.
Hold on. So you got 0 for the x-intercept? Does it cross the x-axis? I think it doesn't. I think it should be nothing. And then
Yeah,
the
that's-
y-intercept, you
and the
said
y-intercept.
0, what'd you say? 0.3? Okay, perfect. I'm trusting you on that one.
Dang it, Connor.
All right, quickly. Asymptotes for this one. I want to go fast, okay, because we're running out of time. We got 4 minutes. The vertical asymptote is what? Did anybody do this one? -4 over x plus 1. Let's go type it in. Okay, so vertical one. X equals 0. Because again, there's no h. And then k for this one is 1. You with me? Okay, so now I've got to put real points on this thing, okay? We're running out of time. I got to go quickly. I'm just going to sketch this in, but again, I want 2 real points on each piece whenever you do it. But I'm just sketching this in because I know what it looks like because this is the 4th time I've done this, okay? There it is. This one looks a little different than the others. Why does it look different? What's in the front? On the A? A negative, okay? Need to realize that. This is reflected, okay? So it's just going to change a few things. The domain, it won't change. This is still negative infinity. As I move from left to right, I'm stopping at 0.
0 to positive infinity.
Okay? And then range is going to be stopping at, from bottom to top, I'm stopping at 1, right? Okay, there's no holes. The x's go left and right forever. The y's are both going to stop at the horizontal asymptote, just like the others did. Okay, this is where it changes. This is the only change. Is that increasing or decreasing from left to right? It's increasing. Do we all see that? As I move from left to right on either one of these, I increase. Okay, so I still copy the domain, but I put it on the increasing line. So then decreasing is nothing, and then I would get my x and y intercepts from Desmos, okay? In this case, there is no y-intercept. What's the x-intercept? Okay. Your homework is the next page, 7, 8, and 9. Okay, we'll go over them next class, so please try to have them done by then, okay? They are very similar to these. If you have questions, come get help. Thank you.